At a price of $198.20 per ounce, the daily demand of Verbog is 600 ounces. At a price of $186.50, the daily demand for Verbog is 1250, 1,250 ounces. So the first thing we're asked to do is use this information to create two ordered pairs of the form quantity demanded, comma, price per ounce. We're given two quantities of demand. Demand was 600 and demand was 1,250. And we're also given two prices per ounce, 198.20 and 186.50. So we're going to create ordered pairs that relate those quantities to each other. Use a comma to separate the ordered pairs. All right. So one of my ordered pairs, well, one of them is this 198.20 for 600 ounces. So 600 is the quantity that was demanded. 198.20 is the price, comma. The next ordered pair is the one where we have $186.50 and the quantity demanded is 1,250 ounces. So the price went down and demand went up. 1,250 ounces at the price of $186.50. So those are the two ordered pairs we were asked for. All right, once we find the two ordered pairs, the next thing says to create a linear demand function, P in terms of Q, the quantity of units demanded, and then use the ordered pairs. So we're using the ordered pairs up here to come up with a linear demand function. All right, so let's see. So what we're going to do first is we need to find the slope. The slope. In this case, my ordered pairs are of the form quantity Q, comma, price P. So quantity Q, comma, price P are the ordered pairs. So the slopes are going to be P, or the slope is going to be P2 minus P1 over Q2 minus Q1, because we are replacing the x's and y's with q's and p's. So in this case here, the numerator is a difference in the prices. It's going to be that 186.50 minus the 198.20. That's the difference in price. And in the denominator, we're going to have the difference in quantity. So that's going to be the 1250 minus the 600. And we get that the slope is equal to, that's going to be negative 11.7 on top over 650, which if you divide, you get negative 0.018. Negative 0.018. All right, once we have that, the next thing we want to do is we want to put this into point-slope form. Remembering we don't have x's and y's, we have p's and q's. Point-slope form is going to be p minus p1 equals m times q minus q1. And then we just plug in all the information. So p is the variable p. That's going to be the variable price, the price variable. Then p1 is the fixed price. P1, I use p1 as this one right here, 198.20. So 198.20. And that's going to be equal to m, which we just found m to be negative 0.018. And that's going to be times q minus q1. And q1 comes from the same point. It's 600. So q1 is 600. Now I'm going to go through and I'm just going to put this in slope-intercept form. So to put this in slope-intercept form, I distribute the slope here, and I get that p minus 198.2 is equal to negative 0.018 q, and then that's going to be plus 2 209 when I do the distribution. And then, I mean, not plus 209, oops. Getting ahead of myself there a little bit. That's going to be plus 10.8. Plus 10.8. Then I add the 198.2. Add the 198.2. And that's where this gives me that P is equal to negative 0.018 Q plus 209. And this is the demand function right here. Or actually, if you feed this the demand, it'll give you the price. So that's what this last question is. It says, find the price per ounce when the quantity demanded is 750. So what I'm doing there is I'm finding the price when the quantity Q is 750. So this gives me the price of 195.50. So this is the price for which the quantity demanded is 750.